Hi guys, how are you? I miss you. I'm going to walk you through how to do some of the word problems in the distance learning packet. So if you want to turn all the way to page 10, you're going to go through. Hopefully yours is all completed by now, right? I only did what I needed to in here to show you online, but here we go. So I want to look at these systems of equations applications. So this is applying systems to real life problems. So there's quite a few in here, and I'm going to do 5 of them for you today. The first one I want to look at is number 1. So we'll do number 1. We will do number 3. I'll just help you set that up. It's not too bad. I'll do number 4 for you. And then I thought these two might be tricky, so 8 and 9. I'm not sure if I'll go in that order, but those are going to be the problems we look at today. Okay, so let's take a look at number 1. It says a flat for sale sign has a perimeter of 58 inches. The length is 5 inches longer than the width. Find the width. Now, if you know anything about for sale signs, they're usually rectangular in shape, maybe not that long, but they're rectangles, usually. It says it has a perimeter of 58. Perimeter, think rim, the rim of the shape, okay? So it has a perimeter of 58 inches. Let's think back to what we know about rectangles. In rectangles, opposite sides are equal, so the top and the bottom are equal, and the left and the right are equal. Opposite sides are equal and parallel. We don't really need the parallel piece for this one, but if they all add to 58, I can use an L for length, and I know that this bottom side is also going to be L, right? I can use L's to represent the length and then W's to represent the width. Now, if I know that all sides add up to 58 inches, I can just add my variables and say that they equal 58. So I can say a width plus another width plus a length equals 58. I can also combine like terms, so I have 2 W's, so that would be 2W plus 2L equals 58. Now you can see I'm running out of room, so that's why I created boxes for you, which I think aren't quite big enough, but they'll work. So, and we're going to do number 1 in the box. But looking back at the problem, okay, let's write this. 2W plus 2L equals 58. Let's write it in the box. 2 lengths plus 2 widths has to equal 58. Now, maybe I reversed that because maybe on my document with you I said 2 widths plus 2 lengths equals 58. It doesn't matter, okay? You can write 2 widths plus 2 lengths equals 58. Now, we need another equation because it's a system of equations. So let's go back to the problem we were looking at. And it says the length is 5 inches longer than the width. Find the width. So they don't even want the ordered pair, they just want the width. But if the length is 5 inches longer than the width, length is, so we can go L equals 5 inches longer than the width. So 5 plus W. Now there you go, you've got your system, you've got your 2 equations, and what we can do is use substitution or graphing, but there's no graph, so why use graphing? We're going to use substitution to solve this. So I'm going to take this length right here, and I'm going to plug it in for L in that first equation. It's really nice that this one was already solved for a variable, so I didn't have to do that piece. So I'm going to go 2, but instead of times L, I'm going to go 5 plus W and insert that. That's the substitution part. Plus 2W equals 58. Now I have a little bit of distributive property. When the number is outside the parentheses, you need to multiply. 2 times 5 is 10. 2 times W is 2W. So now it looks something like this. 10 plus 2W plus 2W equals 58. I have like terms I can add up here. That would be 4 W's. And now I need to solve for this variable, so I'm going to move the 10 to the other side by subtracting, because you want to do the opposite. So now you have 4W equals 48. On the last step, I always want to divide by that number in front of the variable, so I'm going to divide by 4, pull it off to the side if you don't have that memorized. 4 goes into 4 one time, subtract, bring down. 4 times 2 is 8. There you go. Goes in 12 times. So W, 4 divided by 4 is 1 whole. So 1 times W is just W, equals 48 divided by 4 is 12. Okay, so the W stands for the width. So the width is 12. We need to make sure we're precise and we have the units. So it is in inches, so 12 inches. I believe that's all they asked for the width. So the width is 12 inches. It's helpful to write your answer in a statement because it's a word problem, but you don't have to. W equals 12 inches will be fine with me. Now, let's say you did have to figure out the ordered pair. What you would do is plug that 12 right back in here to get your length. So let's just do it because we usually do. Instead of the W, I'm going to put the 12, right? Because W is 12. So that means the length is 17 inches. So your ordered pair, we'll just keep it in alphabetical order, would be 17, 12. Okay? All right, and that is how you do number 1. Watch this as many times as it takes to get it. All right, guys, we'll go on to the next one. Okay, the next problem we're going to look at is 3. I'm pretty sure you guys can do 2. So if we look at 3, this is a different kind of problem. I actually didn't need to create 2. I didn't need to create a system. But thinking about it, you know, you are setting up the different angles and you're using algebraic expressions, but I'm not really needing a system here. So let me show you 3. The 3 angles in a triangle always add up to 180 degrees. So all 3 of these angles in a triangle will add up to 180 degrees. So this one plus this one plus this one. Now, I guess you could write x plus y plus z equals 180, but you don't really need to do that because it says if one angle in a triangle is 72 degrees. So let's actually use the box because it's a bigger area. So let's go to number 3 and let's draw a triangle. It said one of the angles is 72 degrees. So I'm just going to go ahead and put that in one of the angles. Now it says the 3 angles in a triangle always add up to 180. Okay, we got that. If one angle in the triangle is 72 degrees and the second is 3 times the third, don't let that confuse you, okay? The second, so another angle in the triangle, is 3 times the third one. What are the 3 angles? Okay, so I don't know the third one, so let's go ahead and put that the third one is x. Then they said the second angle is 3 times the third. So this angle right in here is going to be 3x. Now, using the piece of information they gave us before, which we also studied at the beginning of our time together, was that these 3 angles add up to 180. That's the triangle sum theorem. So I'm going to go ahead and add those up. 3x plus x plus 72 equals 180 degrees. Make sure at the end you do put the degrees. So we're going to go ahead and add these because they're like terms. So you have 4x plus 72 equals 180. And then I think you guys have it from here. You have to move the 72 over and then at the end divide by 4. And that's going to give you the third angle, right? So to get the second angle, you would have to times x by 3. Now let's see what the question's asking for. What are the 3 angles? So you're going to need to list all 3, okay? You're going to need to list the angles. So we know one is 72 degrees. You'll list the next one, and then you'll list the third one. And that will be your answer to this problem. I'm not going to give it away because I think you guys can take it from here. All right, going back to this page, I think I'd like to try number 4 for you. It's just a different way of thinking about things, and you had to pull in a little science. It says Kang and Hector live 30.6 miles apart. in southeastern Missouri. They decide to bicycle towards each other and meet somewhere in between. Hector's rate of speed, so his speed, is 70% of King's. Okay, so we don't know Hector's, but we do know it's 70% of King's speed. They start out at the same time. That's important, so we don't have to worry about time. And they meet 3 hours apart. Okay, so that's going to be their time. So 3 hours later, they're going to meet. That doesn't mean they're halfway in between here, okay? We have to set up a picture and create our equations. So let's go to the box. It said that Hector and King live 30.6 miles apart. So I'm just going to draw a little diagram. I don't really know how big to make it, but I'm going to say that this represents that total distance of 30.6 miles. And we'll say that this is Hector's house and this is King's house. Okay, so we know they're 30.6 miles apart. Now, they're going to meet. We don't know if it's directly in the middle. We don't know that. So I'm just going to put a line here. I'm not going to put what these distances are, but I do know from here to here, we can call that distance 1, right? You might not have thought to do that. You could have used an X. And then from here to here, this will be distance 2. Okay, so they're going to meet somewhere. You know, they're going to go this way and try to meet in the middle, but we don't know if it's directly in the middle or not. So we're going to say that where they meet from here to here would be distance 1. That'd be Hector's distance that he traveled. And then here's King's distance that he traveled. Okay, I do know that this whole distance, right, is 30.6. So I've got my first equation. Distance 1 plus distance 2 has to equal 30.6 miles. I'm going to leave off the units for now and add it later. Now I need some other equations. Okay, if you think about science, you learned, and math too. I don't know how much we've used it this year, but the distance that's covered would be your rate times time. Okay, so distance always equals your speed, your rate, times time. So I'm going to go ahead and write that down. So this distance that Hector covers, right, his distance, distance 1, is going to equal his rate times time. Let me go back because I don't know, was it King's or Hector's that was 70%? So you always have to go back and reread. All right, let's see. They decide to bicycle towards each other and meet somewhere in between. Hector's rate of speed is 70% of King's. Okay, so whatever King's is, Hector's is 70% of that. So we're going to let King be the variable r. So I'm going to go ahead and do his distance first. So distance 2 equals rate times time. Okay, so Hector's distance, if his speed is 70% of King's, and I don't know if you know, rate is speed. I'm not sure how well you know your distance formula. If Hector's speed is 70% of King's, you can times r by 0.7. So I'm going to say 70% here, just so you know. You divide it by 100, backs that decimal up twice, so it'd be 0.7. So 70% or 0.7. So we're going to put 0.7 r, and right, that's his rate times time. I'm just using parentheses so that I know that it's 0.7 of King's speed, right? And that's King's speed with an r. Okay, cool. So we have both of these. They gave us another piece of information. They said 3 hours later. So we know the time. I'm going to go ahead and plug that in so that I don't have another variable. I'm going to plug in 3, and it took them both 3 hours, so you get to put a 3 in for both of them. So Hector's distance will equal 0.7 r times 3. And King's distance will be 3 times r, because you'll just plug the 3 in for time. 3r. Now 0.7 times 3, I can just pull that off on this side here. I don't want my paper to get too messy here. It's 21, right? Move the decimal over 1, so 2.1. So this becomes Hector's distance equals 2.1 times r. All right, now I've got Hector's distance in terms of the distance formula. I've got King's distance in terms of the distance formula. So I actually have 3 equations. So this system has that the total distance is 30.6. I have that distance 1 equals 2.1 r. I have distance 2 equals 3r. So I'm going to use a little substitution. Since I know distance 1 plus distance 2 is 30.6 miles, I'm going to go ahead and plug in distance 1. And I'm going to plug in distance 2. And then I'm going to solve for r, which is the rate. Okay, here we go. So I'm going to use this one. But instead of d1, I'm going to put what d1 equals. Instead of d2, I'm going to put what distance 2 equals. So this is King's distance, right? 3 times r. Equals 30.6. I'm going to have to go into this box. So maybe you guys need another sheet of paper. Or I should have made these boxes bigger. Okay, 2.1 plus 3. If you, again, pull that on the side of your paper if you need to see it. 3.0 plus 2.1 is 5.1. So it's going to be 5.1r because they're like terms. Now I'm just going to go ahead and divide both sides by the number in front of the variable, which is 5.1. So r will equal 30.6 divided by 5.1. Go ahead and use your calculator for that. You could do it by hand. I did it by hand the first time. Oops, just showed you the answer there, but that's okay. So we've got 30.6 divided by 5.1, and that is 6. Okay, so the speed is 6 miles per hour. How did I know it was miles per hour? Because they were saying that the distance was miles, so my unit for the distance is miles, and then they told me it was 3 hours. So this must be 6 miles per hour. Okay, that's the speed for King, right? King's speed was r. They didn't ask for King's speed. They said they start out at the same time and meet 3 hours later. Find Hector's rate of speed. So find his speed, his rate. Okay, well, r is King. Hector is 70% of King's. We're going to just use the knowledge that it's 70% of King's. So since it's 70% of King's, I'm going to go ahead and times 6 by 0.7, right? Because 70% is 0.7. So if Hector's speed is 70% of King's, I just have to take King's speed and times by 0.7. Seven times 6, right? 42. 6 times 0 is 0. Add 4 is 4. Bring that decimal over once. So 4.2. So Hector's speed, or rate, is 4.2 miles per hour. Okay? Very reasonable. Now, if you would have gotten something super quick, you should probably, like if you got 42, if you got 60 miles per hour, you know, he's not in a car. They're in a bicycle. So you have to also think about that. 4.2 miles per hour would work. Okay, this is slow, but they said he's going 70% of King, so you never know. All right, see, had to think through that. They're not all the same, and the reason why this one is a system is because we set up 3 equations, not just 2. You have to kind of pull in everything you know, and then each problem is done differently. All right, that's how you do that one. Okay, now we're going to look at number 9 because I think that might throw you off. The others I think you'll be able to do just fine. So let's read this one. Tim and Judy mix 2 kinds of feed for pedigreed dogs. They wish to make 24 pounds of feed worth 53 cents per pound by mixing one kind that's 37 cents per pound with another worth 91 cents per pound. How many pounds of the cheaper kind should they use in the mix? Round your answer to the nearest pound if necessary. When you see this, round your answer to the nearest pound if necessary. You're probably going to have a decimal in your problem. Don't freak out. They say you can round it to the nearest whole number, which is nice. Okay, so Tim and Judy want to make this mix of dog food. They want to use a cheap brand, right? Or a cheaper one that's 37 cents per pound. And they want to take it with like an expensive one that's 91 cents per pound and come up with, like a happy medium, a 53 cent per pound dog food. So the best way I can do this is by drawing a picture. And I think it would help you too. So go to number 9. What's nice is there's no 11 and 12, so you can use this space. I only gave you 10 problems. So we can use these 2 for our problem, which will be helpful. So since we are mixing 2 kinds of dog food to get this 53 cent per pound mixture, I'm going to just create a problem that looks like canisters, right? So I've got one type of dog food plus another type of dog food is going to equal my perfect little mixture here that I want. Now, I know that I want 24 pounds of this final mixture. They wish to make 24 pounds of feed. Okay, so I like to put my weight on top in my picture. So this is going to be 24 pounds. Now, they want it to be worth 53 cents per pound. So I'm just going to put 53 cents at the bottom. Okay, now, looking at this problem, it says the other 2 kinds of dog food, I've got one at 37 cents a pound and one at 91 cents a pound, but they don't tell me how many pounds of each. So I'm going to let variables represent those. So I need one kind of mixture at 37 cents per pound. And I need another kind of mixture, so we have to use a different variable because it's a different mixture. It's not the same one. A different amount of mixture at 91 cents a pound. And let me just check those. See, I'm always going back and checking my numbers. Yep, 37 cents a pound, 91 cents a pound. All right, so here's where you're going to get your system of equations. So this amount of dog food, we don't know what it is, plus this amount has to equal 24 pounds, right? So that's a given. The 2 that you're mixing has to equal 24 pounds. I'm going to leave the units off again and add it in at the end. We know that our X and Y is standing for pounds. This mixture is they want it at 37 cents a pound. 37 cents a pound. So if this is the number of pounds, then it would be 0.37 times that. Okay? 37 cents per pound. So 37 cents per pound plus 91 cents per pound. So we're going to go ahead and multiply those. Would have to equal this one being 53 cents per pound. So I'm just going to go ahead and multiply 0.53 times 24. You're going to need a calculator for this problem. I think it's really helpful. 0.53 times 24, 12.72. I'm thinking that we don't want to deal with the decimals, so let's go ahead and times everything by 100 because that would take care of this because they all need to move twice, so it's perfect. So I'm going to times every single thing in this second equation by 100. So I'm going to times this by 100, this by 100, and this by 100. Remember I taught you that you can manipulate equations to make them look better. So now my 2 equations are x plus y equals 24 and 37x plus 91y equals 1,272. Okay, so now the decimal's gone. So this is just going to be a system of equations now where you're going to solve one for a variable and plug it into the other. So let's go ahead and get you started on that, and then I think you can finish it. So I'm going to take this one and solve for y. And then I'll plug it into this second one because this is much easier to solve for y. So I've got x plus y equals 24. I'm just going to move over my x. And so I've got y equals 24 minus x. Okay, so that's what y is. I'm going to go ahead and plug this in for the y in the second equation. So now my work looks like 37x plus 91 times 24 minus x equals 1272. You're going to go ahead and distribute this. 91 times 24, you can again use your calculator. And that's 2,184. Minus 91 times x equals 1272. If you're wondering, I'm going to get a negative variable here, that's okay, because when you move this guy over to the other side, you'll have a negative over here. And at the end, the negatives are going to cancel. So I'm going to go ahead and let you finish this. All you have to do is add these like terms. You will have a negative. Move this 2,184 over to the right side, and you'll have a negative over here. Once you divide, oh, actually, let me just finish it for you because you will have to round. So go ahead, 91 minus 37, 54, but negative because there's more negatives. And then you're going to move over the 2,184. Go ahead and do this in your calculator. 1272 minus 1272 minus 2184. And you get negative 912. And then now when you do your division, 912 divided by 54, you get a negative divided by a negative, so that's a positive 16.888. And remember, they said you could round it to the nearest whole. So if you rounded to the nearest tenth, that would be 16.9, right? But nearest whole would be about, let's go ahead and use the about symbol on both of these, about 17. Okay, so 17 pounds. Now we have to check, is that the cheaper mixture or the more expensive mixture? So we need to go up and see which one was our X. And X was the cheaper mixture. So you are technically done at 17 pounds. I'm going to go ahead and put it right here. It's not 170, that's 17 lbs pounds, 17 pounds, okay? Or if you want to write it out, 17 pounds. The more expensive mixture then would be, because I said both of them need to add to 24, so it'd be 17 plus something equals 24, so you could just subtract 24 from 17, and that's 7. So there's about 7 pounds of the more expensive mixture, 17 pounds of the cheaper mixture to get your 24 pounds. All right, and that is how you do that problem. Okay, now let's look at one more. Let's look at number 8. It's a little bit different than some of the other problems, but it's pretty interesting. It says, Marty received an inheritance of $40,000, so she received this money. She invested some of it at 9% and the rest at 12%. So she's investing her money to try to make even more money. Her total annual income from the investments was $3,900. So that's what she got from investing it at the 9% and the 12%. And then it said find the amount she invested at 9% because it never told you the amount. So let's go to page 8 in our packet right here. And it says she received an inheritance of $40,000. She invested some of it at 9% and the rest of it at 12%. So since she split this investment, we're going to split it into two amounts, X and Y. Okay, so X is going to be the amount she invested at 9%. Y is going to equal the amount she invested at 12%. Okay, if you write it out, it'll help you understand that these two amounts has to equal her $40,000 amount. So we're going to go ahead and put X plus Y equals $40,000 because she's separating this $40,000 into two amounts, some that she wants to invest at 9% and some that she wants to invest at 12%. But you know, combined, it has to be her $40,000. Now let's figure out the investment piece. It says she invested some of it at 9%, some at 12%, and then she earned $3,900 from that investment. So investing this amount at 9%, 9% as a decimal is 0.09. Okay, and then she invested this amount at 12%, so as a decimal that would be 0.12. Has to equal what she earned from that investment. So 9% of X plus 12% of Y equals $3,900. I guess this is dollars too. But I'll go ahead and, like the other problems, leave off my units till the end. Okay, now, just like that mixture problem, I know I did them out of order, but I'm going to times everything by 100, and then I don't have my decimals anymore. If those numbers are 2, well, you know what? I did the mixture problem, changing it. I won't change this one. Okay, so what I'm going to do is I'm going to solve this one for Y because it's easier to. I'm just going to move over the X. I'm going to subtract X from both sides. And that'll leave me with Y equals 40,000 minus X. So now I'm going to take this amount and plug it in right here. I'm going to do the substituting. I'm going to solve by substitution. So I'm going to use the second equation, but instead of the Y, I'm going to put 40,000 minus X. Now, I'm going to go ahead and use the calculator for this, since I'm not timesing everything by 100. You could, but I'm just not going to on this one because I did it on the mixture problem. That's 4,800. So I've got 0.09x plus 4,800 minus 0.12x. Now, if you're wondering how I did that, I just did 0.12 times 40,000 on my calculator and then did 0.12 times x, which is negative 0.12x, equals 3,900. So now I have my two like terms here. I'm going to go ahead and combine those. I'll grab the calculator again and say 0.09 minus 0.12. That's a negative 0.3. 03, excuse me. If I write that correctly, it's negative 0.03. X. Now, if you're wondering why it's negative, don't worry, because we're going to get a negative when we move this guy to the other side. So we're going to move 4,800 because we need to get x by itself. That cancels out. I have negative 0.03x equaling 3,900 minus 4,800. You can do that one in your head, but I'll just show you. Is negative 900. See that? We got our negative, so we're okay. Because in real life problems, right, negatives don't always make sense. Especially on an investing problem. You can't invest a negative amount of money. That's just not going to work. The bank's going to be like, what are you talking about? Okay. So we're going to divide both sides by negative 0.03. And what's nice is a negative divided by a negative cancels out. And then let's put that into our calculator, 900. I don't put the signs because I already know a negative divided by a negative is a positive. So 900 divided by, make sure you're careful here, 0.03, and that gives me $30,000. That's okay, that's not the whole amount, right? He invested $40,000, so you know that he invested, X stands for the amount invested at 9%, so $30,000 was invested at 9%. Which means only $10,000 was invested at 12%. 9% 30,000, 12% 10,000. How did I get that? You can plug it right back into this first equation right here. So if you want to see that, you could say X, but instead of X, put 30,000 plus Y equals 40,000. I'm kind of out of room, but then you would subtract 30,000 to both sides. I know this is messy, but then that would be Y equals 10,000. Okay? So Y equals 10,000, X equals 30,000. So your coordinate would be, if you were writing it as an ordered pair, 30,000, 10,000. Because that's your X, that's your Y. But let's see what the question asked for. It said, find the amount she invested at 9%. So you can see that X was our amount at 9%. We got X as 30 grand. So $30,000 is the answer. 30,000 was invested at 9%. Now, these are story problems, so it would be awesome if your answers were in a complete sentence, but this is good enough. I didn't do it on my other problems, but just a thing to take note of when you have a real life problem. It's nice at the end to state what your answer is. $30,000 was invested at 9%. All right, there you go. All right, guys, good luck on the rest of these. I think you can do them. If you think through them, go slowly. I'll have the answers up on Friday morning. All right, adios.